The model-driven development process has been successfully completed, with all its steps finalized. The models have been transformed from the CIM level to the PSM level. Now, my goal is to generate solution code from these PSM models. To achieve this, we've defined an additional process that implements these models in C# based on the .NET platform. I navigate to the Process Management section and select the second process responsible for generating code from the models. Similar to the previous process, if this one isn't already configured, I need to set it up. Upon entering this process, I find that the configuration hasn't been defined yet. Therefore, I proceed to create a configuration for it. This process consists of two phases. First, the mapping phase brings the models from the PSM level to the code level. Next, in the subsequent phase, it converts the code level models into files that can be downloaded and stored on the system. Initially, I set up a configuration for it. First, I select the problem domain, which specifies the input and output models needed for the configuration of the tasks. Next, I delve into the configuration section to set up the tasks that constitute this process. Detailed instructions for configuring these tasks are provided in an attached file, along with accompanying videos. For instance, the first task involves selecting Model 4 as the input model and Model 17 as the output model. Similarly, for the second task, I designate Model 4 as the input and Model 17 as the output. I pause the video, configure the settings, and then return. After configuring the task, I'm ready to create an executable process. Clicking the Create Executable Process button accomplishes this. Now I can proceed to run the process. In the configuration section, I click the Execute Process button to access the execution page. Notably, this process doesn't involve manual tasks. All tasks execute automatically upon clicking the button. To obtain the code, I head to the Problem Domain section and select the Download Project Code option. Here, I specify the problem domain and choose the output model containing the solution code. In this case, model number 19, Project Solution. Rather than storing the code as plain text, I've modeled it using a simple metamodel. Consequently, the system looks for the file concept. I define a concept called project file as my file. It prompts me for file name information, which I provide via a property called file name. Additionally, I specify the content of the file using a property named content. For the file extension, I use an attribute called extension. Lastly, I indicate that the file storage path can be derived from the value of the relative path property. This information, stored in the model, guides the code generator in creating a compressed file containing the project code. After downloading the code, I extract it into a folder to explore its contents. I find commands such as create order, revoke order, and cancel order. Handlers have been created for each of these commands, with collaborators added to their respective class constructors. The code also includes controllers, e.g., order controller, defined entities, event classes, e.g., order created, order canceled, and corresponding event handlers. Notably, an event handler for customer-created handler is also generated. Additionally, interfaces, e.g., iCustomer repository, iOrder repository, and their methods are present in the folder. This code represents the solution for my project, written in C# on the .NET platform.